Okay, welcome everyone to ISC 2, Awareness Month. And today we have the privilege of Ian Butterworth. So his presentation is on bridging IT and OT security consideration for critical infrastructure. And I do know this field require a lot by our government. So his presentation is on operation technology, OT. Systems are the backbone of modern infrastructure, ensuring the safety and reliable operation of essential services such as water treatment, energy distribution, transportation, and healthcare. So these interconnected systems play a crucial role in our daily lives, from providing clean water and powering our homes to enabling life-saving medical equipment. So this presentation explored the evolution of OT technology, highlighting how increased connectivity between OT system, enterprise network, and the cloud has enhanced efficiency, but also introduced new security risks. As these systems become more integrated, they also become more vulnerable to cyber threats that can disrupt critical operation. We will examine real-world examples of OT systems across industry, how they function, and introduce the growing challenges in securing them against potential attacks. So Mr. Ian Butterworth, P.Eng, professional engineer, is a professional engineer with over 30 years of experience in automation, control system, and operation technology, OT security. His expertise spans from SCADA to DCS, PLC, RTU, and flow measurement system, integrated diverse technology across oil and gas, pipelines, and critical infrastructure. His project experience includes work in North America, the Middle East, South America, and Asia. Ian is an active participant in Industry Standard Committee, and he's also served as a PEGAS investigative committee, contributing to the professional integrity and oversight of engineering practices. And welcome, Ian.
Great. Yeah. Thanks, Vincent. Is my audio good? I guess they can hear me
Yep.
well enough. Okay, great. Yeah. Yeah. Thank you to IC2 for this chance. My degree is actually in mechanical engineering, but I've done control systems automation, and it's a very multidisciplinary field. And when I started, I'm gonna tell you my introduction here, but when I started in the business, things were not so interconnected many decades ago. So I mean, even Windows didn't exist. Controlling Windows was a big deal then, that systems would use Microsoft Windows to control because it, wasn't deterministic, wasn't reliable. Even Ethernet wasn't necessarily there because it wasn't as deterministic. But now here we are, everything's Ethernet and pretty well everything's Windows. So we have to, of course, deal with the advantages and disadvantages of that. So this is just a general slide. Of course, OT systems, OT meaning operational technology, to distinguish it from IT, information technology. It's really where a term kind of becoming more common now is cyber physical, where, you have the cyber part meet the physical part, right? Now, also was about critical infrastructure. Now, different countries have different definitions of critical infrastructure. Some critical infrastructure is very obvious. Obviously, hospitals, major pipelines, our water treatment plants, those sort of things. The electrical grid, they're obviously critical infrastructure. Generally, in Canada, the federal government, I think it's Public Safety Canada, they deem who and whose facilities are deemed to be critical infrastructure. So just a brief history lesson. It all started really, when I started, it was a transition period of, control rooms with, switches and lights, and everything's wired, with a copper wire taking, 12 volts or 24 volts, and, direct signals to gauges and recorders, and, computers were there to some extent. And what the other part of it as an engineer, back then, these systems, these OT systems, are generally engineered systems, and things should be deterministic and engineered and follow proper engineering processes and procedures. And now, of course, with networking IT, there's that whole aspect of the IT aspect blending in with the engineering aspect. So that is a big consideration because when you do engineering, you have professional responsibility for public safety, facility safety. So there's more focus on risk and these sort of things, right? So just an idea of the evolution. So, I mean, I started, I guess, somewhere around here and you can see it was the transition. I mean, the old relays and diodes and those sort of systems and even dedicated networking, serial interfaces and those sort of things were mostly in place then. And then, and then Ethernet came out and then, and then we had year Y2K, which is, computers were pretty well everywhere by that point, and after that, there was just more and more about involving more commodity equipment and the enterprise. And of course, we're moved on to cloud and good old AI is the next thing to worry about. So, like I said, there's a lot of advantages to all this interconnection. Remote monitoring, predictive maintenance, a lot on the corporate side, sharing all that data. Business decisions, that's been around for 20 plus years, really. Getting the data flowing, but it does raise considerations. So, but having everything interconnected and open opens up, of course, to the bad actors too, right? The other thing unique about OT is there's a lot of old things out there. I mean, there are PLCs, if you program logic controllers that are literally 30 years old that are still running out there. So, and that's the nature of the industry, partly because they're still reliable, and partly just it's a lot of money to replace, like do a whole control system replacement in a plant. It's a huge job. But you have obviously shut down the plant. You have a lot of engineering there, replacing it. Usually the other thing is a lot of times the documentation and the information on that existing system, maybe some scrap piece of paper in some guy's drawer somewhere. So, it's a big job to replace these systems. If it's still working, they try and extend it as long as possible. And I'm sure all you are familiar, obviously, once you go up into cloud, you open up to all kinds of things, cloud connectivity. It has its advantages, but you have to be aware of the additional risk. And in general, as I said, safety is important in these OT systems. Risk, OT, I mean, an IT system goes down, then people, maybe they can't reach the printer or they maybe don't get their internet connection. But, when the operational OT system goes down, then you may lose visibility of your plant. You may have a process running or a factory or a pipeline. Suddenly it's out there running blind, right? So that's a whole different ballgame. The other thing, and I'll touch on that later, of course, is the whole supply chain threat of interruptions to your networking or from any kind of reason, which can interrupt your operations. And I'll speak to that later a bit more. So I put this in just so to understanding because it is a big point. And this could be a whole multi-hour course for that matter, as we know, on risk assessment, and pretty well IT, OT are familiar with risk assessment. And it is a challenge because the threats keep changing. AI has raised that a whole new level. Because once somebody announces a vulnerability, people could be attacking it, literally within hours, generating attacks everywhere. So you have the evolution of the threats. You have so many dependencies. I don't know, you guys have heard recently some open source libraries have been compromised, and then vendors have those embedded into their software. And then it just spreads by the million. So that's another recent issue because the whole internet, the whole networking, the whole open source world, evolve when everybody was good guys. But now once the bad actors get in there, you see that there are weaknesses in that system that you have to be very aware of. There's something, I don't think I mentioned it later on, but there's something in control system you call the software bill of materials, just to understand what software you have on everything. And then at least you can know what vulnerabilities, keep track of that. So yeah, I think I more or less touched on all the risk. It's not a whole talk on the risk. That's, as I said, a whole other day or more. And there are other methods of evaluating risks that are potentially more empirical than risk matrices as well. There are other methods. If you want to read some good books, Douglas Hubbard has some really good books on like failure risk management, failure of IT risk management. I highly recommend his books. It gives you a whole new view of risk. So, I talked about, of course, we have digital transformation. I don't know if you guys have heard that term. It's common right now. I think it's more the past few years talked about companies' digital transformation, digital twins, all these things. I think probably AI term is kind of taken over as the buzzword in that now. IoT, of course, Internet of Things. I mean, probably those of us that have worked in SCADA now, maybe you all don't know what's SCADA is supervisory control and data acquisition. So it's for broadly distributed systems like, say, an electrical distribution grid or a pipeline over wide geography. That's where you would have SCADA to bring in data and control from a diverse area with diverse protocols and devices. You may have valves, you may have, transformers, pumps, various things. So for some of us that have done SCADA for many decades, the idea of IoT, SCADA was really doing that before it was so common. I guess IoT differentiator is the IoT devices are pretty well independent, and most times they go to the cloud. They don't go through say you have your own host for that data. It goes to the cloud, and then you get it from the cloud. Of course, real time, digital transformation, very similar. And again, increased security challenges. So actually, I just saw this a few days back. I don't know I hope they're online. They can see it more legibly. It just gives an idea of the different type of threats on OT systems. This is a Fortinet report. It was out just a week ago, actually, or less. So just the type of intrusions, phishing is still there, or it'll always be there. Still ransomware, email compromises, denial of service, malware. I'm sure you're all familiar with all those kind of threats. But I guess that is an interesting one that, IoT network device compromise, that didn't used to be an issue, but now, people buy their Amazon.com no name. I don't know. I mean, some company goes, I just work with a company. They just purchased a standalone webcam, right? But you have to make sure you don't just buy that on, Alibaba or Amazon or something, because you need to completely vet, that camera. And that was a lot of work to find the right camera brand, one that did everything you wanted, didn't use the cloud, could operate all locally on your local network. So that's the sort of thing, when you're in OT, you have to be extremely careful about that. And obviously that camera cost, probably 3 or 4 times the price of, well, or maybe more than that times the price of, Amazon camera, but that's what you have to do. So yeah, so I talked about the old PLCs. That's an actual system I was on. That's an old Allen Bradley, now Rockwell PLC 5. So you imagine you have all these out in the field. You imagine all the field wirings going into here, like to say, oh, we got to upgrade that. You imagine the work involved. I mean, they do make like kits now, the manufacturers, where you can get you can put in their new PLC, and they make like adapters that will take these wires and put them into their new system. So that's a whole business of its own, but that's what you're at with OT. And then of course the newer ones, I don't know if this looks like it's just input output module, but the processors generally they'll have, Ethernet ports on them. You can also, of course, put different cards in these racks and do various communication protocols, Ethernet or other industrial ones. But, generally talking about patching, generally these are not frequently patched because if I'm gonna patch this, I have to shut my plant down, right? So they're not patched, they're out there, they can have a lot of vulnerabilities, but you make sure that nobody's gonna get on that network. That's really with OT, like you just can't patch these. You gotta shut your whole plant down. Maybe once every 2 to 3 years, you have a plant shutdown, maybe you can patch them. Generally there's no authentication, things aren't encrypted to these, because again, OT, you way off. Also, can you troubleshoot it? If you have a problem, can you get it back going? If you start, the newer PLCs can do full, encryption, put all your encryption keys here and there, but then there's a fear, of course, then what if you don't do that right and suddenly you can't access one of these controllers? So it's a whole different ball game, right? Then your plant could be blind and you might not be able to get into your system. Yeah, like I said, OT 25 years, even longer on some systems, like these are end of life like 15 years ago or 10 years ago or something. So, I mean, there's a whole other interesting thing, like people are, and there are companies and people like scouring eBay for used, when people replace these, they sell off the pieces. People scouring for those and then reselling them. And then you get the scary thing, like some companies resell them, but are you sure that like even if you have this controller and this card, well, you get a new card, it has to be the right firmware version, even maybe hardware version of that card, or it won't work with that rack and this thing. So that's kind of the OT challenge. It's not always interchangeable. So I had a little fun with this drawing because I didn't want to give any customer secrets away. This is a real system. Pardon the glitch here, but I just generated this from some tools. It just shows. So what is this? This is what, about 4 facilities and 1, 2, 3, about 3 pipelines. Not a huge system, just a reasonably large system. These are all the communication links between all these sites. Including redundancy through, like, a lot of times you may have even a microwave link, or you might have 2 cellular networks, so you'll have like backup communication links. Like you can see, I don't know what site that is or what that is, but you got 2 communication links back to this, and you can see here kind of where it's all going. We've got two primary communication servers here that get all the data out. So you can see how they're linking everywhere, these 2 guys. So one is hot and one is standby. I mean, IT, your critical equipment, you certainly have redundancy, your Cisco switches are redundant and so on, the critical stuff too. So I mean, we have that in common, and actually a lot of the networking equipment in the system is also regular Cisco components. That's a whole other discussion about Cisco vulnerabilities and all that. If you should, if your corporate site has one, you've got one everywhere, but, so I put that in just as an idea of how complex the networking is in some of these larger systems, and every one of these links has to be up, like, the primary link and all these has to be up all the time. It's not like it comes and goes, right? It's gotta be there 24/7, right? And reliable, and your data has to be reliable, you're like from here to here, well, one of the talk distance is probably 200, I don't know, it's like 350 kilometers away or so, right, on a pipeline. So, and you're pulling it with, I don't know if you know Modbus protocol, Modbus over TCP. It's a very simple protocol used it's been around for what, 40 years, 50 years. It's still loved. I mean, you may have heard of MQTT. That's the latest favorite protocol for a lot of things, used in IoT a lot. But I mean, the thing about Modbus, it's a very simple protocol. It's reliable. It's easy to troubleshoot. And so it's basically over TCP. I think probably the majority of this is Modbus protocol. So I talked about this again. You've got ransomware and OTs. Supply chain attacks. An interesting one is recently, well, maybe recently, inverters for, and even some battery controllers that have been used en masse have had basically even secret communication devices in those controllers. So you're building all these solar farms, or there's all this renewable energy, and then you have this embedded rogue software basically. I put in as well remote user laptop compromise. I've been on a site where they had that. People come in either like a contractor comes into site, they plug their laptop in to do, upload a program, and then their laptop has some malware on it and out it goes to the network. So fortunately it was found by monitoring and did not spread. Partly the networks were segmented and so it didn't, well, it caused a lot of political mess, but no huge mess. I mean, yeah. So, the interesting one is like nation state attacks. I'm sure you guys have heard of nation state attacks and so on, but the thing is nation state attacks, as soon as somebody knows about them, and now also with AI able to sort of modify and change those, like those attacks are now, once they're out, they're not a nation state attack anymore. Anybody can pretty well do it, right? So that's the challenge, well, in all aspects of cybersecurity, not just OT, right? Is these threats and these attacks. What was which one? Oh, it was the Microsoft SharePoint. There was a recent vulnerability in SharePoint, like self-hosted SharePoint. Well, you would do that, but anyways, but actually, yeah, actually, it was the U.S. government part of the nuclear branch of the U.S. government got hacked. Like, I think they said it was a day before the vulnerability was disclosed. So, I mean, fortunately, it was only data. It wasn't any nuclear plants shutting down or melting or anything. But so I originally had a list that went way back, but time is not infinite here to go over it. And I thought these might be illustrative. And I'm reasonably familiar with these. So I think this one. So the interesting thing, like those programmable controllers. So it talks about a safety instrumented system. So the safety instrumented system, in this case, Triconics in Saudi Arabia, which is why they named it that. That basically controls your most, call it, dangerous parts of your plant, right? It must absolutely perform. When you say shut down, it must shut down. What happened in this, and it is a lot of these controllers, the older ones, newer ones, they have a mechanical switch in them, right? That goes like run, what is it called? Run, program, off, generally speaking, right? So again, a lot of people just leave it in program, which lets it run and lets people program remotely, which is what happens in this case. It wasn't, because once you have it run, and if you want to do maintenance, then somebody's got to walk out to that panel up there and turn the switch, right? And the funny thing on some of them is the switch, it's easy to accidentally turn it past the run spot into the stop spot. So anyways, yeah, so that talks to security is also physical security. I think OT does rely on that a lot, right? Is physical security, as they say, guns, guards, gates, I think is the term. The old smart water a little bit overhyped, but it does point out, and may not be as bad as they did, but it points out that there are a lot of small systems, and this would be critical infrastructure, but a very small town, right? So those towns don't have the resources necessarily to have the full sort of OT security oversight on a little water treatment plant for some little town or village, right? In Florida, I guess. So I think they basically left open access to their remote, team viewer or whatever they had so that the guy could go in and support it. Now, unfortunately, and again, this is part of good engineering practice in the actual control logic in their PLC, they had a limit set that you couldn't set, the concentration, ridiculously high. Like, so you do other controls to compensate and be safe, right? Colonial Pipeline, I don't know how many of you guys have heard about Colonial, but that one was pretty big, and that was really the answer of how everything's entangled, like. Well, for electrical grid or pipelines, so pipelines. Daily, they send data of what they've produced, what's flowed through the lines. But they also get instructions of what to pump coming from corporate into the control system for those pipelines, right? So the problem with Colonial was they had this compromise, I believe, on their corporate side, but they had to shut down everything because they had no way to sort of tell the pipelines what to pump. Plus, they didn't trust that they were potentially compromised on the, call it the OT pipeline side. So, and actually, Jaguar in UK, you guys hear about that? It was the last month or two, right? Similar story. They were all shut down. Was it like, I think it was like UK government was gonna give, I don't know, $500 million or pounds, I guess, or whatever to like, because what happened then, manufacturers again being critical, they run on their supply chain of all the small people that feed them, their, what they call it, just in time manufacturing and everything, right? Suddenly, if you're a big manufacturer, you shut down your plant, well, all your suppliers are gonna be shut down too, because they can't give you their supplies. So is that OT or not OT? Well, it certainly shut down the OT. So, yeah, and huge economic impact. So some of these get pretty sophisticated, like industry. I'm not super familiar with that, but they were able to get access, obviously, and issue control commands. Not obviously not a good thing. Then you have it at other levels. They're hacktivists going after all kinds of assets. I mean, it's that cyber war idea. There been, Netflix shows and you name it on that, as we know. Some more accurate than others. So there's an emerging subject coming out of Idaho National Labs in Idaho, obviously. It's a branch of the US federal government. They're kind of leaders in I guess you'd say critical infrastructure security, among other things. You don't need to read that. I just wanted to show this, for example, and you can go online. The nice thing about any US government publication, and I validated that before I put it in here, is it's free and open. There's no copyright on it. If it's made by a US government branch, anybody can use it. I mean, you should credit it, but it's usable by anybody. So that means like all the NIST standards, the US government, they're freely available, right? Which is great. So this field hopefully is coming more into OT, that the idea that there should be proper engineering behind the OT, obviously networking and communication side of it. And then looking at the consequences. Like all OT systems have a risk assessment, what if this vessel overpressures, what's gonna happen? And usually you have a mechanical pressure gauge, so at least, that's not gonna be a bad consequence, but maybe there's other areas, like what if you overflow it, what are if you're hacked and it overflows, like what's your backup? I've got an example related to that later. Just at the time here, I think I'm doing okay. I'm kind of repeating myself a bit. I guess I could probably streamline this a bit, but repeating is also good, then you learn, right? I mean, it's such a vast topic, as we know, but it's a whole career and even one niche of this. So yeah, so really the difference, IT, information technology, OT, operational technology. I mean, I hadn't thought about it till I did this, and that really is like it's technology to operate stuff versus technology to move information around. And actually, you think about it, that's probably the best definition going, right? So you've all, I'm sure, seen the CIA triad, right? Now, but the bottom line is that's great, it's particularly availability, integrity, confidentiality and OT to some degree, but safety is the core, right? That everything is around safety. And so you need security controls. again, you don't wanna, I mean, you don't wanna harm people or the environment or, damage your facilities or, and then next in priority, I guess, is to operate and be available and online. And, confidentiality, certainly there are processes, probably the Coca-Cola beverage plant, their secret Coca-Cola batch recipe. Obviously that's probably where, confidentiality is more important. There's a whole aspect of well, in the electrical industry too, but I'm more familiar with, oil and gas where, if you're producing hydrocarbons, you have what's called custody transfer, where you have a contract with someone, that you say, we're gonna sell you this mix of hydrocarbons, you're gonna take it within this contract. So that information about, okay, what's the analysis of those hydrocarbons, how much did we sell to you and so on, that would be confidential also. Now, it's not strictly encrypted and all this kind of things, but it certainly is confidential data. So. Yeah, so the basic approach is segmenting your network, fail-safe design, that's, I guess that's a term that comes up in OT. I've actually not really ever heard it in IT, and maybe is fail-safe, right? So if I have a valve to shut a pipeline, if that valve loses its or a plant, whatever, if that valve loses electricity, loses its signal, it shuts, right? That would be fail-safe. Yeah, this is a very general slide here, just continuous monitoring. Again, you gotta know what's going on. You don't want to be blind. So this, I don't know if you guys have seen this sort of digital IT controls, engineered controls. It was actually it was Idaho National Labs. There was a presentation they gave, and I'd never thought of it that way. Fairly obvious, but like what layer, like if you have endpoint protection, like, I don't know, CrowdStrike or something, where does that fall in this, call it pyramid or whatever, reverse pyramid, right? Well, it actually falls really at the PPE level, right? Like you should have, like that should be your last line of defense, right? So you should design your system without thinking you just, use CrowdStrike or whatever other competitive product, right? So, and a lot of people are using CrowdStrike for their OT, for sure. I mean, I'm supporting that on a number of systems. It's good. I'm not saying bad things about it or anything. But really you have to look at, these hazards. So things like, allowing people to get onto the network, which would bring threats, right? Like you're gonna block USB key access, right? So I guess that would be an engineering control. You disable all the USB ports, for example, or your firewalls isolating people from coming into OT. That's again, it's in this level here, right? So you have to look at all those layers of control. And right, and again, coordinate that between IT and OT at that dividing line. So I put this in because everyone likes the Purdue model, so I'm sure everyone's heard of it. But I was gonna jump in there and say it's just a model, okay? And it's great. I mean, it was when did I look up? It was more modern than I thought it was, although some guys have told me it came out early. It was supposedly early 90s, but there were I think inklings of that model before then. It's great as kind of a reference model, but you really should look at segmentation. Now that's where IEC 62443, they have the zones of conduits model, which really, I mean, it's basically, I guess, an extension or expansion of this. So you assess your system and you look at what logically is a zone. I mean, similar, this would be a zone, this would be a zone, this would be a zone, but these zones might be in separate zones within the zone, if that makes sense. Or call it in the level that may be multiple zones in a level, depending how critical they are. And the same with your conduits. protect the data, but also protect the direction of the data. If you have there are also things called data diodes. I'm sure you guys have heard the term where you only allow one-way flow of the data. I mean, a true data diode is literally an optical fiber that it has an optical transmitter on one end and an optical receiver on the other, and there's no way data can go the other way. That's a true data diode. And then fancy software on both ends to deal with getting the data through there without the handshakes and everything that you get with bidirectional. So yeah, Purdue model is talked about in OT, and that's where we talk about the big thing there is you talk about this level 3.5. Now, demilitarized zone it's more an OT DMZ in Cisco's terms, because this a true DMZ is more on your IT side, and it's outside of your IT is a separate zone on the internet. That's not what this is. It's really a zone between these layers. And actually this arrow should have been going that way. Because you really only want, if you have any traffic coming in to here, it's only from this zone, and it comes from already like an authenticated host or server in 3.5. So if someone's coming in for remote access, they may be on enterprise or out of the internet, they'll come in through a VPN generally onto a jump server. And then that jumps, then you authenticate for a VPN, typically, two-factor authentication, get that VPN established. That will give you access to the jump server, which you'll authenticate to, and then that would have, depending on what user you are, give you access to different devices down at this level. That's pretty typical. Now, there are the next level up from that, which a lot of companies are going that way, is a more dedicated remote access solution, because jump servers, running Windows and using remote desktop protocol down here is not the most robust way. So there are solutions where they basically, instead of this, you have a more dedicated server that actually just sends, keystrokes and mouse clicks down to the devices at the lower levels, and they just push basically pixels back up to you, so you're not using RDP protocol, which has its own issues and vulnerabilities. That's again a whole other subject. And subject around that is password management as well. So yeah, and I better move along. I see the time is ticking here. So good. We can get through quickly. I put this in just for fun. You guys can look it up. This was, it was 20 years ago or so, but they wanted to prove to the doubters that cybersecurity was important. So they actually put a real generator in there, and they had a computer send it out of phase signals to the breaker, and the thing literally blew up. So you can find it online. So this is something I was working on recently. Like, we set up a new Windows 2019 server, because that's what the system has, and the software, the control system software supports it. And I was like, look at all this bloody crap going out, like traffic trying to go out. So that's what we face, and well, everybody faces that, but OT, we don't want this stuff trying to go out. I mean, it doesn't go out of that subnet, but it's a pain. So we're gonna basically go on this dang server and disable whatever's trying to talk out. So yeah, just an example. I talked about cyber-informed engineering. So this is an example from INL where a hypothetical city had all these little pump stations, and the pump vendor wanted to then say, hey, I wanna control the speed of this pump with my cloud. And they're like, well, should we do that? So they kind of thought, what do we do? Because the idea was, what if somebody tried to start and stop the pump too frequently? Then, like, big pumps, big motors, they don't like being start and stop too frequently. So they decided, yeah, we can do that, but they added a mechanical, well, not electromechanical kind of relay in there that basically set a time limit when you stopped it until you could start it. So that, I know, 10 minutes or 15 minutes or whatever. So if somebody tried to hack this and start and stop that last control would stop that. Again, engineered control, right? So Um, I think I won't go off this one because we're getting on time. It's just kind of was a more typical pipeline example again, showing that it's vastly distributed and we have the different equipment, but I think for time, we won't kind of dig into this. I guess it'd been cool if everybody was here and we could have a workshop or something, but maybe another day. So something also, I was on another client, they'd been running for what, 3 years, and it was time to, they were having a plant shut down for maintenance on their facilities, all of them, pipeline, plants, everything. So, we were able to do our software updates, but the amount you have to prepare for that as best you can and still hope that everything works. I mean, they did Windows updates, we did some application updates. We had to, as best we could, because some companies have literally an offline system that duplicates a subset of their main system. So any patching, any testing, they can do offline. Of course, you can't simulate everything, but to some degree, we couldn't do that. I was able to take the site virtual machines that I was updating and have them in the office and actually test the software updates, run through all the steps, and sure enough, the vendor hadn't described it completely. So I got my surprises when a week before when I was doing it in my office. So that's another thing about OT. I mean, rollback, IT, I mean, IT obviously critical. IT is fundamental to do that as well, right? I mean, if you shut down your. So, I mean, the other interesting thing I ran into is, you should be monitoring your logs, your servers, et cetera, et cetera. And even talking to one of the major vendors, I mean, they did not understand the concept that we don't want traffic going into our OT system. It should only be outgoing. So that was, again, vendor, they should know better these days. Yeah, so good. Okay, so I zoomed through those to catch up a bit because time was passing by. Leave a few minutes at the end. So this was also a very recent thing, and I thought it was important. So I don't know if you guys have heard, in the electrical grid, there's something called NERC-CIP, National Electric Regulatory Council, I think. Actually, I don't know the acronym, I should know the acronym. It's a very prescriptive cybersecurity legal requirements for electrical transmission and distribution. It applies here, it applies in the US. And and this was like just a week or two ago, but I thought it was super interesting because these guys just studied it and said standards are great, but particularly NERC, it's very specific, and then you end up ticking the box playing the game, right? So if you do use standards and things, it's better to have less prescriptive and do things that make sense. So I think this is kind of the summary, like OT and IT, you kind of trust it. And it's all intertwined now, whether we like it or not. So that's where I think you need to work together to have IT, OT understand, okay, it's entwined, but again, what's engineered, what affects safety, what affects asset integrity? That's critical, right? And I think promote, and is really IT, OT, supposedly that there's this divide, between IT, OT, but really is to bring the engineering teams, bring operations, bring the people together. So there's collaboration and learning from each other, because certainly pretty well all engineers don't learn, the level of IT that the experienced IT people have after they get out of school. So this is kind of and this is kind of a program. Again, you need your management to support this. If you're working shouting into the dark, or whatever you say, you need full commitment. You need to know what you have, need to know your risks. Then security management plan, CSA Z246 talks about that. There's this, well, SP 882 is a general OT. I think there's some NIST standards about security management plans, and some ISO standards. ISA is great as well, 62443. Again, NERC which I talked about, and really document that and follow it. That's, collaboration. And that's what I like to say is engineering work with OT, work with OT. Actually, I meant to say IT right there. That's a typo. Engineering and OT operations, OT people really work with the IT people, kind of as the guardrails. And I've done that many times. Like IT are certainly, generally the experts on the networking, but they need to understand, networking, software updates, all that. But, collaborating and giving the right guidance at the right time so that things are done safely and properly. So I tried to hurry a little at the end. I saw the clock ticking. I guess anyone wants to reach out, you can find me on LinkedIn or send me an email, collaborate or hire me or fire me or praise, not praise, whatever. Always happy to talk about this. I think, I was lucky, I guess, that I started hands-on, commissioning these facilities in the field, being out on site, working with operations people, kind of understanding these systems, with boots on the ground, so to speak. And that kind of gives me the good, I don't know, whatever you want to call it, just a view of the practical side of it. But when I talk to the IT people, certainly they make my, they got a lot more, they know a lot more than I've forgotten on networking. So, yeah, I don't know, there's maybe questions or,
Oh, thank you. Thank you very much, Ian.
yeah.
That was really interesting. So, anyone have any question, you can either unmute, or you can always, if you are in person, just shout out. So I have a question here. The whole IT industry is really, or just basically say, the whole IT industry is really fascinating, and say thank you for
Okay.
sharing.
Yeah, thank you.
Yeah. And
Hard question.
you want a hard questions? Uh, anyone here have any hard questions? Uh, My hard question will be, how does IT find a job in OT?
Yeah,
Can they cross over to the other side? I think most people will want to know.
yeah, I've talked to people about that. I think you can maybe kind of slide into it more than jump into it in a way if you can get closer to the OT side. Um, obviously try and understand these systems. So you end up, again, sometimes getting a job is just being at the right place at the right time, right? And just trying to understand this. What standards are open. I mean, understand the industry. It's, I agree. It's a challenge to go from IT to OT. Even within OT, you have some larger corporations that IT is really trying to drive OT with some potentially scary things going on, right? So there's a whole aspect of sort of the IT telecommunications side as well, which is also fascinating, right? Like microwaves and radios and even the cellular network. So I mean that's potentially a way to go sort of a little closer to IT, but still getting towards OT, right? Um, because we work with some companies where they're providing, like some of these remote sites, literally you have to helicopter in, a valve site on one of these pipelines, you have to take a helicopter in the summer. In the winter, it's frozen, you can drive in. And then, they have a, solar panel and a methane powered generator and they have literally 100-foot cell tower to get over the trees to get the signal out. So, so there's the whole telecoms part of that is pretty fascinating. And that almost crosses over a little more directly from even some of the consumer telecoms in a way, right? Some of it. So, yeah.
I do have a comment here that says, I might ask about Skynet. Might take us 2 hours. I'm not sure about that. And another person, Nolan, was saying division between IT and OT often arises from cultural differences. So, and he also says IT security protects information, while OT security ultimately cares about people's safety. And the question is, mission and mindset are sort of different. How can they unite and collaborate? So, sounds like you talk about, yeah, how can you uh, connect them, collaborate them between the cultural and all this mindset. So how do you?
Well, on that, I mean, in some ways, management and corporate culture, you may have to fight that, right? Yeah, I mean, but as people, getting together, I think, you know, the way I've always seen it, because I started working in the field, commissioning, well, it was compressor stations mostly, sitting there with the operators, understanding in the end, I think you need buy-in, like the operators, if they don't like what IT is trying to push, then you'll get that divide, right? Especially the operators, like they're like, I don't wanna have to log in every time I do this or something, right? So I think it's a people question. You have to have the right people there that will talk. I mean, you gotta try not to be adversarial. Um, I think, the CISOs are generally IT focused and it can be tricky. Just from people I've spoken to with large companies here in town. Yeah, and that's not a real positive answer, but I think, in the end, it's about people being decent with other people, right? And being open and, you know, but certainly people, again, change is hard. Well, I mean, we're in an interesting environment now with, the economy and everything else too, so that can make a challenge too. People may feel threatened that you're taking some of their work away, right? So it's, yeah, was it how to win friends and influence people.
Any questions from here? No.
So yeah, unless I think that part is those soft people skills, not the technical skills, and probably people who go into engineering and IT are not big on the soft people skills. They're big on the technical skills, and that's probably why between IT and OT you have a divide, because it's a lot of people that are more technical and introverted and don't have those soft skills, right? So maybe you need to arrange meetings and get them facilitated by people who are a little more people skill-ish. Um, yeah.
So there's a comment, a question that says that I'm in transportation and every day I worry. Trucks are now connected via API. Ferry transportation is a critical infrastructure in Canada. So any comment on that?
Is it API or?
Yeah, so transportation now. I'm not sure. You say so. This specific case is trucks, right?
Yeah.
And obviously, we got lots of transportation,
Yeah.
driverless car and all that stuff. They're all connected through API. So
Oh, API is just
yeah,
connecting data and so on. Well, trucks, yeah, certainly there have been.
GPS, GIS, and all that stuff. Yeah.
Yeah, I mean, the actual driver behind the wheel is still here. They're still not self-driving, so that's a whole other thing. I mean, the APIs, it's generally, I don't think it's a big danger. I mean, there have been hacks where people have gotten into, hit the brakes in a car remotely and this sort of thing, but I'm not sure they're really credible yet. That said, I mean, now with cars like doing software updates, I think I just read one of the cars that literally they were driving and it was doing a software update while they were driving. So that's a bit scary because you suddenly lose control of your car while you're driving. So yeah, again, it's I guess any technology there's going to be glitches, but it is scary for sure. Wear your seatbelt and keep your eyes open.
Good. So anyone has any other questions?
No.
No? And what about other critical infrastructure like banking and oh hold on, we have one here that says common umbrella uh s- common umbrella, mission and goal could probably get them together and a common umbrella,
Yeah, yeah.
mission and goal. And I see OT being reluctant to implement zoning segmentation. There's obviously an overhead with that clicks login
That's it.
time, while IT believe they are superior since they control those zone and segment. So
That's a good question
yeah.
to point something out. So when you build one of these OT systems, in a general sense, you have all the design inputs that have been, engineered that, this is how everything hooks up. In your office, you get some computers, you program all these controllers, you build your fancy displays, you hook it all up. You go to site, you get the network all going on site, and you may have done that 15 years ago. Now, once that's running and your plant's running, you just like you can't patch the equipment, you start changing that network. Who's gonna push the button to start making those changes? Like, you pretty well need a shutdown. And the other thing is, a lot of these old I mean, if the networking hardware is up to date, supports it, but a lot of these old networks, particularly, they use a lot of internal protocols that are very messy and maybe even not well documented and so on. So if you start trying to re-architect your network, it's a full plant shutdown and a pretty big job. That's why people are hesitant. It's practically the equivalent of a whole new system to do that work.
Yeah, so because it's 7 o'clock now,
Yeah.
so I'm just gonna stop the recording.
Sure.
And so if you guys, for a few more minutes, if you have any questions.